Alright, so in this video, I'm going to be finding out which one is greater, 33 to the power of 44 or 44 to the power of 33. So we want to find out which one is the greater number. So what I'm first going to do is take the power of 1 over 11 on both sides. And the reason I'm doing this is so I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So this turns into 33 to the power of 44 over 11, which is equal to 33 to the power of 4. And I also have 44 to the power of 33 over 11, which is equal to 44 to the power of 3. Now, I'm going to rewrite 33 to the power of 4 as 3 times 11 to the power of 4, and 44 to the power of 3 as 4 times 11 to the power of 3. So now I get 3 to the power of 4 times 11 to the power of 4, or 4 to the power of 3 times 11 to the power of 3. Now, 11 to the power of 4, I'm going to rewrite as 11 to the power of 3 plus 1. So now I get 3 to the power of 4 times 11 to the power of 3 times 11, because 11 to the power of 3 plus 1 is equal to 11 to the power of 3 times 11. Or I still have 4 to the power of 3 times 11 to the power of 3. And now we see that 11 to the power of 3 is present in both of these, so we can just cancel out because it's there for both terms. So I'm just comparing 3 to the power of 4 times 11, or 4 to the power of 3. Now 3 to the power of 4 is 81, so I have 81 times 11, or 4 to the power of 3, which is 64. Now 81 is already greater than 64, and on top of that we're also multiplying by 11, which turns into 891, or 64, meaning 891 is greater, so 33 to the power of 44 is the greater term. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now, x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to, this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now, I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20.